Morning children, we are discussing about chapter 3, that is earth movements and seasons. So the factors affect the seasons. These are the four factors: curvature of the earth, earth's rotation, earth's tilting, and earth revolution around the sun. So we have already discussed about the curvature of the earth and what is the rotation of the earth on its own axis. Okay, now we are going to discuss about earth's tilt and the revolution. Okay, the earth revolves around the sun while rotating around its axis. So as I told you that this is our earth and this is axis. On its axis it revolves from west to east. So while rotating like that, here is the sun, the earth moves around this. Okay, around the sun. That is spin like a top, and at the same time keeps moving forward around the sun. So it's making a rotation as well as this is called as a revolution. The motion of the earth around the sun is called as a revolution. Write down the movement of earth round the sun is called revolution. Okay, so it is called as a revolution, the movement of earth around the sun. Each revolution takes about 365 days and 5.56 hours. So to revolute around the sun, it takes 365 days and 5 hours 56 minutes. Okay, for a revolution. This is the lengthest of the year on the earth. How does this causes the formation of the seasons on the earth? Let us discuss about it. Had the earth just gone round the sun, it would have been meant that a place would have had the same season throughout the year. Okay, so if it is not revolving, then the same season will prevail. The points that get more sunshine would keep getting it throughout the year. In the same way, and the vice versa. So only one side will, when it is face, it will get more heat, and the other will not get. Okay, but this is not so, because the axis of the earth rotation is inclined, and the point in the same direction throughout the year. What do we mean inclined of the axis? So it is inclining on its axis in the different positions we will discuss here. Okay, the earth goes round the sun on a regular path, that is called as a orbit. This is called as a, what is that? Orbit. This is a axis. Okay, this is called as orbital plane. The earth axis is rotation, does not stand vertical 90 degree. So it is not standing 90 degree. The earth does not stand at a vertical position, and it inclines on this plane, but it tilts on it so as to form 66.5 degree angle. In other words, it is tilted by 23 degree. So the 23 degree, the axis will be like this. So the axis it tilting towards 23 degree 5 minutes. As the earth revolves around the sun, earth axis remains tilt in the same direction. So it is moving, but it is tilting. Same direction throughout the year. It keeps pointing to the pole star. which can be seen in the northern sky. You might have seen the pole star. In the northern sky, we can see the pole star. And this is called as a polarity of axis. In this picture, you can see, I will draw this picture. In the different times, the position of the earth is different. So this is sun here, sun. This is the orbit of the X. The earth is here. Okay. Spring in the north. So northern hemisphere, southern hemisphere is there. Spring in north. That is in the reverse side, it's autumn. It's autumn season. So this is March 21st. Okay. And when it comes here, what happens? It is a month of June. Month of June, and summer in the north. Summer in the northern hemisphere. And like that, in the southern hemisphere, it is a winter. It is a June 21st. Like that. When it comes here, in the north, it's autumn, and in the south, it is a spring. After June, it is the position of September 23rd. September 23rd. Then comes here. Okay, so the picture should be here. This is spring, this is autumn. This is the month of March. Okay, so like that, in the December month, here in the north it is a winter, quite opposite. Okay, and it is here summer. It is in December. Okay, December 22nd. See, in this picture you can see that what happens when the earth goes around the sun in this manner. So as the earth moves around, okay, or make a revolution, you can see the seasons in the northern hemisphere and southern hemisphere. Okay, during some months, June, the north hemisphere is tilted toward the sun. So June month, in the month of June, tilting towards the sun. Okay, northern side tilting toward the sun. That's why it is a summer season, and it is away from the sun. That's why it is a winter. And the sun, while is in the some month, the southern hemisphere faces the sun. As a result, when the northern hemisphere has the summer, southern hemisphere it's a winter in the June month. Okay. Then 6 months later, in the December, quite opposite here. So these are the two opposite, these are the two opposite. So in the December month, the positions changes. What happens? Northern hemisphere has a winter. Northern hemisphere has a winter, while in June month, southern hemisphere has a winter. That means this is tilting towards more portion are there facing toward the sun in the southern hemisphere. That's why it is summer here, and it's away from the sun. That's why it is a winter here. In some months like March and September, it is the equator which faces the sun directly, and both the north and southern hemisphere gets a similar amount of energy from the sun. So in these 2 months, March and September months, It happens like so. So from here we can understand that in the different dates, okay, in the different dates, the northern hemisphere and the southern hemisphere, which is tilting more towards the sun, it has the summer, and the other has the winter. What is the temperature belts? So you can understand this point now. Tilting as well as a revolution of the earth. Okay. Temperature belts of the earth. Temperature belts. What are the temperature belts? Let us see how the effect of the tilt of the axis combines with the spherical shape of the earth to influence the distribution of the solar heat over the earth. We saw earlier that when the solar rays strike the earth's surface, they fall straight in the portion which faces the sun directly and falls at an angle. So when it gets a straight sunlight, okay, so it has more heat, and which falls on the angle portion, they are away from the sun and they get the less heat. The angle keeps increasing as we move toward the pole. So this is our equator, these are the two poles. When you are moving toward the pole, the angle gradually increases. As a result, the hotter in the areas which face the sun directly and less hot. So here more hot, here less heat. Okay, toward the pole region that receives the sun ray at an angle. As a result of the tilt of the axis, the area which faces the sun directly keeps shifting throughout the year. In March, the sun shines directly over the equator. In the March month of March, near the equator, the sun directly falls. Okay, the sun ray. While in June, it is the shines directly over the Tropic of Cancer. So this is the Tropic of Cancer. This is Tropic of Capricorn. This is Tropic of Cancer. So March month, equator region gets a high temperature, and in the sun shine directly over it. While in June month, Tropic of Cancer gets more sunlight. Tropic of Cancer in the northern hemisphere. Then in September, as the earth travels further around the sun shines directly over the equator. Okay, so again as it revolving around the sun, so when it gets further around the sun shines directly over the equator. In the month of December, again December, March and December. Then it shines over the Tropic of Capricorn. Now it came to Tropic of Capricorn. This is Tropic of Cancer. Okay, in the month of June. Okay, so June, then December month, then here in December it shines over the Tropic of Capricorn, southern hemisphere, in the month of December. Here, there you can see that there is a belt within which the direct rays of the sun falls at some time of the year and the other. This belt extending from the Tropic of Cancer to Tropic of Capricorn called the tropical belt. So this is called as a tropical belt. Okay, from Tropic of Cancer to Tropic of Capricorn. This belt is called as a, what is that? Tropical belt. Tropical belt. Okay, tropical belt. This belt gets the maximum heat energy from the sun. So tropical belts get the more energy from the sun. June 21st to sun on the Tropic of Cancer, March 21st and September 23rd, sun on the equator. Okay, so June 21st, sun on the Tropic of Cancer, June 21st. Okay, then March 21st and September 23. September 23, sun is on the equator, and December 22nd, here December 22nd, sun is on the Tropic of Cancer. Tropic of Capricorn. On March 21st and December 23rd, throughout the world, the day and night are equal in size. So these are called as equinox. Write down. On March 21st and September 23. Write down. March 21st and September 23rd. The day and night are equal. Day and night are equal throughout the world. Okay, that's why it is called as a equinox. Equinox. Which dates? March 21st and September 23rd are called as a equinox because here on these particular days, in these 2 days, March 21st, September 23, day and night are equal throughout the world. As you move northward and southward of the tropical belt, we reach a region where it gets warm in summer but also very cold in winter. So from tropical belt, if you move towards the north or to the south area, what happens there? Warm in summer and winter is very cold here. This is called as a temperate zone. After this, first tropical, then a temperate zone. Temperate zone. This is called as a temperate zone. Okay, in 9th class, when you come to the geography, you will have a good explanation about these belts. Okay. Temperate zone, the northern portion of the region, snow falls in the winter. Then after, polar region. This is polar region. Okay. If you move further north and the south, the temperate belt, you will reach a polar region. The seasons in this region are very peculiar here. This region is away from the sun during winter months and doesn't get any sunshine. In winter months, polar region, it doesn't get any sunshine. That is, for 6 months there is no sunshine on the pole. For the next 6 months it constant. So here for 6 months there is no sun, and for another 6 months there is a full sun. Okay. A place which has 6 months of day and 6 months of night, even during the day it gets a very slanting rays of the sun. So in the daytime also it gets a very slant sun rays. The sun does not rise high in the sky but only stays just above the sunrise point. So as here we can witness while the afternoon it's the sun is coming to the top, okay, over the head. But in those region, in polar region, it doesn't rise here. Okay, so just above the horizon it remains there. So for the 6 months it is freezing cold, so cold that an entire ocean, Arctic Ocean, remains frozen throughout the year. So everything becomes totally frozen there. So cold that the soil becomes frozen like a hard rock, and the roots of the tree cannot penetrate there. So the soil becomes so hard due to the bitter coldness. So the trees roots cannot penetrate into the soil. So trees just cannot grow in this region. We cannot find the trees here in this polar region. When the sun shines or appears for the other 6 months, the snow melts, part of the sea also melt. Small plants like mosses, lichens, okay, and small plants and some small flowering plants we can see there in this polar region. Okay, so this is all about our chapter 3. I think you might have understood the lesson properly. I will send you the question answers of this lesson. Try to read the textbook copies also and write the question answers. Thank you.